Hello, this is Dr. Hanaa Assil, and this is the final review on the Unit 5 of the A2 Chemistry Edexcel. So far, we were talking about amines, and we were saying that amines are substituents of ammonia. So, ammonia is nitrogen with 3 hydrogens. If we should substitute one of the hydrogens with an R group, which by R group we mean carbon chain, 1 carbon, 2 carbon, 10 carbons, whatever, or with 2 R groups or with 3 R groups, then we have amines. So the one that has only one of its hydrogens replaced, that's a primary amine. So methylamine is a primary amine. If we have 2 of the hydrogens replaced with 2 alkyl groups or R groups, that's a secondary amine. If we have all 3 hydrogens replaced by carbons, then that is a tertiary amine. So for example, this question was saying, deduce the classification of the labeled amine group. Now, this amine group has how many carbons attached to it? It has 3 carbons attached to it. This is a tertiary amine. It doesn't have any of its hydrogens attached to the nitrogen. Amines are miscible with water. They will dissolve in water easily. This is because they can form hydrogen bonds with water. And remember, hydrogen bonds are made with something that has hydrogen attached to an electronegative element. So I can make a hydrogen bond between the hydrogen of the amine and the oxygen of the water, or the lone pairs on the nitrogen and the hydrogen of the water. Remember, hydrogen bonds are straight linear bonds with an angle of 180. Amines are also, when we dissolve them in water, of course an amine is a base, so when dissolved in water it forms an alkaline solution. This is because the lone pair of electrons on the nitrogen can be used to make a dative bond with an H+. So, hydrogen bonds are formed when methylamine dissolves in water. Which structure best represents a hydrogen bond between methylamine and water? Of course, we said the hydrogen bond will be with the nitrogen, not with the hydrogen of the amine. So C and D are wrong. My choice is A or B. Of course, the answer is B because the hydrogen bond has to be linear. So if we say the compound pyridine is used in the synthesis of this compound, like many amines, pyridine is miscible with water and the solution formed is alkaline. Explain each of these properties of pyridine. Of course, we're going to say it's miscible with water because the nitrogen has a lone pair of electrons and can form hydrogen bonds with water, and it can accept H+ ions from water to form hydroxide ions, causing the solution to be alkaline. So the nitrogen has lone pair of electrons that takes H+ from the water, forming hydroxide ions, and this causes the solution to be alkaline. Basicity of amines. Which amines are more basic than which? So you should know that all amines are bases. The nitrogen atom has lone pair of electrons, so it can donate it to form a dative bond with an H+ ion. But which is more basic? Now, if we have an alkyl group attached to the nitrogen, so we have carbons attached to the nitrogens, alkyl groups, or for example, an ethyl group is regarded as electron donating. Electron donating means electrons are given to the nitrogen so that the lone pair of electrons on the nitrogen are more readily available to bond with an H+ ion. So that means an ethyl amine or an alkyl amine is more basic than ammonia. Now, which one is more basic, ammonia or phenylamine? Phenylamine is the one with benzene with an amine group. Now, you should realize that the phenylamine has lone pair of electrons on the nitrogen. These overlap with the pi bonding system in the benzene ring. So the lone pair of electrons of the nitrogen is delocalized into the benzene ring, so it is less available to form a dative bond with H+ ions than in ammonia. So phenylamine is less basic than ammonia, and that means the arrangement of the strength of a base, which depends on availability of the lone pair of electrons, means we have alkyl amines are stronger bases than ammonia, and ammonia is a stronger base than phenylamine or its substitutes. So for example, this question says when dilute hydrochloric acid is added to butylamine, the solution is allowed to evaporate to dryness. A white solid forms. What is the formula of the white solid? So if I add acid to butylamine, this is butylamine. We add acid, the nitrogen, lone pair of electrons on the nitrogen will form a dative bond with the hydrogen. So we get this form, which is an ammonium chloride product. So that is my product. So how do we prepare amines? One method is by reaction of ammonia with halogenoalkanes. So this is a nucleophilic substitution reaction in which the NH2 replaces the halogen to form the amine. This is in presence of excess hot ethanolic ammonia, or this is hot ammonia in ethanol. The excess ammonia is used to remove the HBr as it is formed to prevent any further reaction. What is the mechanism of this nucleophilic substitution? You need to know. The lone pair of electrons on the nitrogen of the ammonia attacks the slightly positive carbon attached to the halogen. The electrons between the carbon and the halogen go to the slightly negative halogen to form this kind of product plus Br minus, and then the H plus is removed to form the amine. What is an organic product of the reaction between ethylamine and chloroethane? So we're trying to react ethylamine. So this is an amine that already has one ethyl group, and I'm reacting it with chloroethane, and we said that means the nitrogen will be attached to the carbon that had the chlorine. So my product is this compound, the amine with two alkyl groups attached to it. Another method of making amines is reduction with lithium aluminium hydride in dry ether. This changes the nitrile or the cyanide group into an amine group. Of course, the nitrile is formed by reacting the halogenoalkane with potassium cyanide in ethanol and heated under reflux in order to get the butyl nitrile, and then we add lithium aluminium hydride, and this gives the amine. So this question says amines may be prepared by reduction of nitriles. Identify the nitrile and the reducing agent used to prepare butyl amine. So if I want to make butyl amine, that's that compound on the right, what do I start with? I start with, of course, I'm trying to make butyl amine, so I start with butane nitrile, and the reactant is lithium aluminium hydride. Remember, we could also use hydrogen in presence of nickel. Another method is reduction of nitrobenzene. So if I'm trying to make phenylamine from nitrobenzene, I do a reduction reaction using tin in presence of concentrated HCl. Remember, So reactions, remember amines react with acyl chlorides to form amides, and this is how we make amides. So the lone pair of electrons on the amine attacks the slightly positive carbon of the acyl chloride, and the electrons between the carbon and oxygen go to the slightly negative oxygen, and then this goes back from the oxygen to the to make the double bond of the carbonyl, and the Cl is released. So this question says, explain how the structures of ethanoyl chloride and compound A enable them to react, forming 2-ethanoyl amino benzoic acid, which is that product up there. So you should remember that when we're reacting with the ethanoyl chloride, the lone pairs of electrons on the nitrogen of the amine group attacks the partially positive carbon atom on the carbonyl of the ethanoyl chloride. The CCl bond breaks and the electrons move to the chlorine to form a chloride ion. Please remember this mechanism. So the lone pair of electrons on the nitrogen attack the slightly positive carbon of the carbonyl, and the carbon Cl bond breaks up to form the amine with that acyl group on it. Reactions of aromatic amines with nitrous acid. This reaction is very important. The product that we get from this kind of reaction is called a diazonium salt, and this is used to prepare many other compounds which we will talk about in organic synthesis. So remember, if I have phenylamine, I react it with sodium nitrite and HCl. What is formed is called a diazonium salt. So this is benzene diazonium chloride. Now, it's important that we do this reaction below 10 degrees Celsius. Usually we say it is done at 5 degrees Celsius using ice. This is because the product is unstable. It would decompose easily if there is a higher temperature to give nitrogen gas. Now, this diazonium salt that we made can react to form other products. This is called a coupling reaction. So benzene diazonium ions react with phenol, for example, to form this azo compound. This is called an azo product, and this is used to make many products that have specific colors. Other brightly colored dyes may be prepared by using other kinds of benzene compounds or aryl compounds instead of phenol. So whatever we add to that diazonium salt, it attaches to the carbon number 4 of the benzene ring. So this question, for example, says a reaction scheme for the preparation of an azo dye from phenylamine is shown. What are the reagents and conditions for step 1? Remember to change the phenylamine into the diazonium salt. We use sodium nitrite and HCl at 5 degrees Celsius. Which reagent and conditions are used for step 2? So in step 2, I'm trying to make this compound. That means I'm trying to add that part. So that part is added using reaction with the part with the 2 benzenes and 1 OH in presence of alkaline conditions. Remember, coupling reactions happen in alkaline. We said, how do we make amides? Amides are made when amines react with acyl chloride. So we can start with something like ethanoyl chloride. In presence of ammonia, this will form ethanamide. So amides are formed from reaction of amines with acyl chlorides. We could also make as many different kinds as needed. The reaction here, remember, releases hydrogen chloride, which is observed as white fumes. So amides, you should know, are neutral compounds. They are compounds that have C double bond O N. So this is an amide if it is hydrolyzed. If it's hydrolyzed in presence of acid, it gives the acid plus the amine. If it is hydrolyzed in presence of a base, then it gives the sodium salt plus the amine. Of course, this is very similar to hydrolysis of esters. Reduction of amides. Amides may be reduced using lithium aluminum hydride, and that gives back the amine. So this is changing the amide into an amine using lithium aluminum hydride, of course, in presence of dry ether. What is an amino acid? An amino acid is something that has a carbon attached to both N and C. So we have both an amine group on one side and an acid group on the other. Remember that amino acids in neutral solution are referred to as Witter ions, in which the acid part is COO minus and the amine part is NH3 plus. This is in neutral. Now adding acid, we go to a lower pH. In that case, the NH3 plus is the same, but the acid now has its hydrogen on it, so the acid group is a COOH. This is what happens in presence of acids. In presence of bases, the pH is higher, the amine part is NH2, and the acid part is in the form of COO minus. So, for example, this question says the amino acid 2-amino propanoic acid exists as a Witter ion at pH 6. What would be the structure of 2-amino propanoic acid at pH 9? So, of course, we said a Witter ion means the amine part is NH3 plus and the acid part is COO minus. But if we put it at pH 9, that means in alkaline solution, then which of these would exist? We said the amine part remains NH2 and the acidic part becomes COO minus at high pH. Amino acids have high melting point, and this is due to the strong ionic bonds between molecules. So one acid group of one amino acid and the amine of the other amino acids, there is ionic bond between them, and this needs a lot. What about this question? It's talking about the proton NMR, high resolution proton NMR spectrum of an amino acid called valine. So this is valine, and we want the splitting patterns for the protons shown in bold. So the CH3s have one hydrogen on the neighboring carbon, so that would be a doublet. What about the hydrogen attached to the carbon? Now this hydrogen attached to the carbon in the middle has CH3 and H on neighboring hydrogens. We have a total of 7 protons on neighboring hydrogens, so this would be an octet. Addition polymerization is where the monomers are unsaturated with double bonds, and we join them all together by opening the double bond and making new single bonds between the monomers. The polymers formed have strong covalent bonds, so they are non-biodegradable, accumulate in dump sites, and when burnt they release harmful gases. This is the disadvantage of the use of polymers. Of course, to draw a polymer, we look at the 2 carbons that have the double bond. We draw them with a single bond on the right, bond on the left, and a bracket to indicate that this part is repeated n times. And then we see each carbon is bonded to what? So that carbon is bonded to 2 hydrogens. We write that. That carbon is bonded to a hydrogen and a C2H5. And if the monomer is called but1-ene, then the polymer is called the same name, polybut1-ene. Polymer of propene, again, look at the double bond, make it single, bond on the right and bond on the left. Then each carbon is bonded to what? This is bonded to 2 hydrogens. The other one is bonded to a hydrogen and a carbon that is bonded to 3 hydrogens. Again, if I'm starting with propene, then my polymer is polypropene. The same way we draw all the polymers that are starting with a double bond. This, for example, is something that has an alcohol and a double bond, so this is actually ethanol. Again, we open the double bond and we make the polymer, and that would be the name of the polymer. Propenamide, again, you just look at the 2 carbons that have the double bond and draw the polymer. So, for example, this structure, what is the repeat unit of the polymer formed from this? Now, we look for the double bond. The polymer will be joined from the double bond, make it into a single, bond on the right and bond on the left. So, which one is the polymer? You will find that this is the same as what is up there. Then the other type of polymerization is called condensation polymerization, and in this case we have a diamine and a diacid, or a dialcohol and a diacid. So in this case, the long chain molecule is made by joining many small molecules together, so this is polymerization, but it is condensation because the monomers have active groups on both ends and are joined together by removal of small molecules. We did not remove any molecule when we were doing addition polymerization, but here we remove an H and an OH, so we're basically removing a water molecule. If we're talking about polyamides, then they're formed from diamine and diacid, and they are joined together by an amide. So, for example, this is the structure of nylon 66, and we're asked to deduce the structural formula of the monomers from which this polymer was made. And notice that it is drawn up there as a skeletal formula, but they're asking for the structural formula. So, first of all, where are we going to break it up? We break it up at the amide linkage. So the part on the left would be an acid or an acyl chloride, and the part on the right would be a diamine. So this is how we draw it, or this is how we write it as structural formula. Explain why polyamides have higher melting temperatures than polyalkenes. You should realize that amides can form hydrogen bonding between their molecules, while alkenes have only London dispersion forces between them. So the polyamides have intermolecular hydrogen bonds, which are stronger than the London forces between the molecules of polyalkenes. Hydrogen bonds need more energy to be broken. Proteins. What are proteins? They are polymers. They are natural polyamides, and they can be referred to as polypeptides. They are made from units of amino acids. So each unit, one end acid, the other end amine, and we join the acid end of one to the amine end of the other. This forms a peptide linkage or amide linkage, so they are actually polyamides. So if we're told draw the structure of the dipeptide, dipeptide means I'm going to join 2 of these formed from phenylalanine. So we said the acid of one joins to the amine of the other to form an amide linkage. So the dipeptide would have a structure like this. How many different amino acids form the repeat unit of the polymer shown? Of course, the amino acids are joined with amide linkages. So each amide linkage you're going to break up so that you have one unit of amino acids. If they are the same, then you count them only once, because the question says how many different amino acids. So actually, for this one, I have only 4 different amino acids because 2 of them are similar to another 2. So the total number of different amino acids from this repeat unit are 4. Which type of compound cannot be a monomer in the formation of polyamides? Remember, we said polyamides are made from amino acids or diacyl chlorides with diamines, but you cannot start from amides. Okay, so if we have a diamine with a diacyl chloride, that would form a polyamide, but I cannot start with an amide as a monomer. This is another type of questions where he says 740 milligram tablet of painkiller contains 4% of a certain molecule, which he referred to as PVP, by mass. Calculate the number of molecules of PVP in the tablet. So the tablet is 740 milligrams, and we're told that 4% of that is PVP. That means the mass of the PVP is 0.0296, and we were told in the question that the polymer has a total molecular mass of 90,000. So that means the number of moles, mass over molecular mass, is this number of moles. We're asked for number of molecules. Of course, how do we get number of molecules? It is that number of moles times Avogadro's number. So we end up with this number of molecules. Okay, the last chapter that we had was organic synthesis, and this is methods of preparing a certain end product from something that we start with. And one of the main important reagents that we use is Grignard reagent. Grignard reagent is used to increase the length of a carbon chain. So if I'm starting with something, for example, that has 3 carbons, I want to make 4 carbons, I have to use Grignard reagent. Now, how do we make Grignard reagent? It's from magnesium reacting with an alkyl halide. That would give what we call Grignard reagent. This reaction is done in presence of ether. Now, I can take this and react it with other molecules to prepare certain compounds. For example, if I react the Grignard with water, and this is how it reacts. The Grignard is an alkyl group, a group of carbons attached to MgCl. That's what we call Grignard reagent. Now, if I react it with water, it forms an alkane. So the R group that I'm starting with takes a hydrogen from the water, and this gives an alkane. I can also react it with aldehydes. Now, if I react it with an aldehyde like methanol, it gives a primary alcohol. If I react it with an aldehyde that has branches in the R group, then we have a secondary alcohol. Please learn how to use all of these. If I react it with a ketone, it gives a tertiary alcohol. And if I react it with carbon dioxide, it would give a carboxylic acid. The mechanism of Grignard reagents. The Grignard reagent, we said, is an alkyl chain attached to magnesium chloride or magnesium bromide. And what happens is the electrons in that bond attack the carbonyl of the compound we're reacting with, and this adds the alkyl group that we had in the Grignard onto the carbonyl, and the double bond O becomes an alcohol group. Please learn the mechanism. So this question says Grignard reagents react with which of these? So remember that the Grignard reagent in the first place is made by reacting magnesium with an alkyl halide, so that gives the Grignard reagent. Now we want to react it with water. If it reacts with water, it forms the alkane, not the primary alcohol. The question says it reacts with all aldehydes given secondary alcohols. Well, some aldehydes would give secondary, but some aldehydes would give primary, so B is wrong. Ketones, when it reacts with ketones, it gives tertiary alcohols, not secondary. When it reacts with carbon dioxide, yes, it gives carboxylic acids. The structure of 2-methyl propyl magnesium bromide is shown. So this is the Grignard. Which statement best describes the circled carbon atom? So the carbon atom that is attached to the magnesium bromide, remember that circled carbon is actually slightly negative, and it acts as a nucleophile because it attacks the carbonyl of the other reactant. So we have many reactions that we need for organic synthesis. Please remember these reactions. We already did this in Unit 5, but some of them we need from the previous units. So for example, to add bromine on a benzene ring, we react with bromine in presence of anhydrous ion 3 bromide. To add a methyl group, this is the Friedel-Crafts, we react with methyl chloride in presence of aluminium chloride. And if we do that to something that already has, if we add a chlorine and aluminium chloride to something that already has a methyl group, then the chloride coming in will be attached to carbon number 2 or carbon number 4. How do we add a nitro group to the benzene? React the benzene with concentrated nitric acid and concentrated sulfuric acid. How do we change this nitrobenzene to phenylamine? We reduce it using tin in presence of concentrated HCl. The methyl benzene, if I want to change it into benzoic acid, we do oxidation reaction, but this is with alkaline potassium permanganate or acidified potassium dichromate. This will oxidize the methyl group to the carboxylic acid. How do we add SO3H onto a benzene? We react the benzene with fuming sulfuric acid, which we said is a mixture of concentrated sulfuric acid and sulfur trioxide. How do we prepare a nitrile, or how do we add a cyanide group? We react the cyanide, potassium cyanide in ethanol. We react it with an alkyl halide. This puts a cyanide, and remember this adds a new carbon to the chain. If we react this with ammonia, again this is nucleophilic substitution, and the NH2 replaces the Br. So this is how we make amines. Remember, this is ammonia in ethanol and heat. This is how to prepare amines from halogenoalkanes. Chlorobenzene, if I want to change that to nitrobenzene, then I add ammonia in presence of copper 1 oxide and 200 degrees Celsius. How do we prepare a diazonium salt? We start with the phenylamine, react with sodium nitrite and HCl, and remember this reaction is done at 5 degrees Celsius to give the diazonium salt. Then we can use this diazonium salt to make a dye, or what we call an azo dye, by reacting, for example, with a benzene ring that has an OH, that's a phenol, or a benzene ring that has any other substituents and the diazonium salts adds to carbon number 4. How do we change an amide to an amine? We reduce using lithium aluminum hydride. Of course, this is in dry ether. How do we prepare the sodium salt from an alcohol that has a methyl group next to it? So remember that this is the iodoform test. It also reacts with the alcohol in which we have a CH3 next to the carbon carrying the OH. So this gives the sodium salt of the acid made by this reaction. Ethanoyl chloride, if I react that with ammonia, this gives the amide. So this is how we make the amide. If I react benzene with ethanoyl chloride in presence of anhydrous aluminum chloride, this adds that group of C double bond OCH3 to the benzene ring. Oxidation of primary alcohol gives aldehyde, and oxidation of the aldehyde gives an acid. Oxidation of a secondary alcohol gives a ketone, and of course a tertiary alcohol cannot be oxidized. Formation of an alkene from an alcohol, we heat with concentrated phosphoric acid or concentrated sulfuric acid actually. If we want to replace the OH of the alcohol with a Br, we react with KBr in concentrated sulfuric. Please revise all of these reactions. All of these will be needed when we do organic synthesis questions. So if I'm starting with an alkyl halide, I want to change it into an amine. I add ammonia, ethanol, heat in a sealed tube. This changes the alkyl halide to an amine. If I want to get an alcohol from an alkyl halide, then I react with aqueous potassium hydroxide and heat. Or aqueous silver nitrate in ethanol would also change the alkyl halide into an alcohol. And again, if we want to add cyanide group, we react the alkyl halide with alcoholic KCl. How do we get an ethene from an alkene from an alkyl halide? Well, we use alcoholic KOH and heat, or KOH in ethanol and heat. This is an elimination reaction and it forms an alkene. Addition reactions of alkenes. If you react with hydrogen in presence of nickel, this adds hydrogen, so it forms the alkane. If I add alkene plus bromine, this is the bromine reaction that with the alkenes, the double bond opens up and puts 1,2-dibromo compound, and this happens at room temperature. So let's take some questions of organic synthesis. So this question said, I'm starting with I'm trying to make 1-chloro-1-phenyl-ethane. This is found in some fruits such as apples and is used to make fragrances, and it can be synthesized from benzene in 3 steps. So we want to start with benzene and we want to make 1-chloro-1-phenyl-ethane in 3 steps. What can we do? The first step could be this, because you're trying to add 2 carbons to the benzene ring. So I can react it with ethanoyl chloride in presence of anhydrous aluminum chloride. This adds the C double bond OCH3 group to the benzene ring. I can then reduce that to form an alcohol using lithium aluminum hydride in dry ether, and then I can change the OH to a chloro compound using PCl5. So what if we're required to make this ester ethyl 2-methyl butanoate starting with but2-ene? So what should we do? Well, if I start with the but2-ene, I can do an addition reaction with HCl to give the chloro compound. And then this was 2-chlorobutane. We can react it with magnesium in presence of ether and make a Grignard reagent. And from this Grignard reagent, if I react with carbon dioxide, we said that would form the carboxylic acid, so that is all the right part of the ester. Reacting this with ethanol would give the required product. Remember, this is esterification using concentrated sulfuric acid as a catalyst. So this is my product. Another question says, devise a synthesis of F using salicylaldehyde, which is given, and bromoethane as the only organic starting materials. Include any other reagents and intermediate compounds and give the essential reaction conditions. So this is the type of questions that you get. So what can we do? We're starting with the salicylaldehyde and we're trying to add that part to form compound F. So basically I can again start from, we're starting with bromoethane. The question says we have bromoethane, so I can use that to make the Grignard reagent. Magnesium powder in dry ether reflux, that gives me the Grignard reagent. I can then react this Grignard reagent with the salicylaldehyde that I have. This would give the alcohol. But then I want the alkene, so I can heat this with concentrated phosphoric acid. That gives me the required product. Another question says, devise a reaction scheme to produce benzoic acid from benzene. So I want to start with benzene. I want to form benzoic acid via bromobenzene and then a Grignard reagent. So we want to make bromobenzene first. That means benzene plus bromine in presence of anhydrous iron 3 bromide. This gives me the bromobenzene. And then the question says use Grignard, so I'm going to react that with magnesium in dry ether. This gives me the Grignard, and then to get benzoic acid, that's benzene with COOH on it, I react that with carbon dioxide to get my required product. Again, this question says, devise a reaction scheme to prepare 2-methyl-butene. So this is 2-methyl-butene from butanone using no more than 4 steps. Again, identify reagents, essential conditions, give the name or structure of each of the intermediate compounds. So we're starting with butanone, but we want to add a methyl group to that part. So I'm going to start with methyl bromide plus magnesium in dry ether. This gives me the Grignard, which I can then react with the butanone. That adds a methyl group on that carbon that had the double bond O, and then I want to form an alkene there, so I react this with concentrated, or actually I heat it with concentrated phosphoric acid to give the required product. Again, this question says, devise a reaction scheme to prepare propane 1-ol from butanone using no more than 4 steps. So again, I can start with butanone, but in this case, I want to remove one of the carbons. So I can do that with iodine in sodium hydroxide. This gives the sodium salt of the acid part on the left. And then I can do hydrolysis with sulfuric acid to give the propanoic acid. Lithium aluminum hydride in dry ether would change the acid into the required alcohol. Another question, devise a synthesis of N-phenyl ethyl ethanamide, which is given from bromomethylbenzene. So again, without the use of Grignard. So here he specifies that we do not want to use Grignard. So in this case, then I can use the nitrile. Remember, nitrile is another method of adding a new carbon. So this compound we're starting with KCN in aqueous ethanol, it gives the nitrile, and then lithium aluminium hydride in dry ether will give an amine there. If I react that with ethanoic chloride, it gives my required product. This is another question in which we're trying to make the azo dye down there, and we want to prepare it from benzene. So how do we go from benzene to that compound which here he names Sudan 1? So the first thing we need to do, we could put a nitro group, and we said that means we react it with concentrated nitric acid, concentrated sulfuric acid. In 55 degrees Celsius, you put a nitro group on the benzene. Now you can reduce that to form a phenylamine using tin and concentrated HCl. And then I can react the phenylamine with sodium nitrite HCl 5 degrees Celsius to make the diazonium salt. And then the diazonium salt I react with the part that I want to add, and this gives me my required. Okay, so we're going to stop here, and I hope this was all useful to you. Thank you for listening, and please keep following the videos, and good luck on your exams.